Okay, so this is part two of solving logs. So let's do a quick review of properties of logs. If you have two logs on one side of the equation, but on the other side you don't have any type of log shown, you want to look for the sign that's in between those two logs, and then you want to use your properties that you learned in my property of logs video. So the first thing I want to do is I want to condense this side of my equation to just one log. So condensed means it's just going to reduce down to um, one log. So I'm going to use the log base 7 that's shown here. And I am going to, um, because I'm subtracting, that means I'm actually dividing. So I'm going to take my values and I'm going to divide them. X divided by x plus 2, and I'm going to set it equal to the 2 that's shown. So now at this point, if I ever see that that's happening, what I'm going to do is I'm going to rewrite it in exponential form because it's already in log form. I don't want to keep it in that form. So I have to get rid of the abbreviation log. Once I do that, then I have 7. Remember, you're going to take your base and you're going to go to the opposite side of the equal sign and then back to the value. So 7 raised to the second power is equal to x divided by x plus 2. 7 squared is really 49, so we will simplify that. 49 is equal to x divided by x plus 2. And if you ever see a fraction and equal to a whole number, make that whole number a fraction just by putting it over 1. And now what I would do is I would cross multiply and simplify. That is simply x is equal to, and when you're cross multiplying, pay attention. If you have an expression, you're going to have to distribute it to everything. So that will be 49 times x, which is 49x. And then it will be plus 49 times 2, which is 98. Now simplifying, I want to subtract x on both sides. And I want to also subtract 98 on both sides. The reason I'm doing that is because I'm putting all of my variables on one side and all of my constants on the other side, which leaves me with negative 98 is equal to 48x. And I'm still solving for x. So therefore, I am going to divide both sides by 48. Let me change this. So once I change both sides, divide both sides by 48, sorry, then I end up with, and I'm just going to move this over here, x is equal to negative 98 over 48. Now I have to go back to my original problem, and I will see that I have an x here. Well, I can't have a negative value. That was talked about in the intro to logs video. So I know in this case, this is the answer is really no solution. Now, I'm not saying that your variable can never be a negative. I am saying that if you simply have an x here, then it cannot be a negative. So for instance, if I had a negative 3 in front of that x, then I could take this negative and I can place it there because a negative times a negative will be a positive. So that's okay. Let's just double check this in the calculator. Let me see if I can find my calculator because me and my mouse seem to, here we go. So this is just me showing you if I were to actually put that negative 98 over 48, what the calculator would tell me. It would tell me that there's an error there. So I don't even have to continue substituting into the rest of it because I already know it's going to be an error. All right. Now this next one, I am going to show you two ways to do it. It's currently in exponential form. So let's say we wanted to rewrite it in log form. What we would do is use the abbreviation log, and we always go from left to right, starting with the first number that you see, and that's our base. So the base of log is also the base of my exponent. Then I go to the opposite side of the equation and then right back to the other side. So log base 5 of 25 will be equal to negative 3x. On the left-hand side, I have the log by itself. So I want to just evaluate that. Evaluate means what is log as a number. So 5 to the what power will give me 25. So if I know that, then I understand that it's simply 2. Log base 5 of 25 is simply 2. So if you wanted to rewrite that so you can better see it, what would make, if I were trying to raise 5 to a power, what would make it equal 25? And again, that answer is 2. And if I set it equal to negative 3x and solve for x, then I'm simply dividing both sides by negative 3. So therefore, x is equal to negative 2/3. That is if I am trying to rewrite it as a log. Another way that you can do this exact same problem, so it's up to you which way that you prefer or your directions. Okay, so I can rewrite this using the same base. Well, they don't look the same. One says 5 and one says 25. Yes, but I can rewrite the 25 as 5 raised to the what power? You're right, 2. So 5 to the second power. And so now that my bases are the same, I can just get rid of them and bring my exponents down. Negative 3x is equal to 2. Again, if I'm solving for x, I am going to divide both sides by what's stopping x from being by itself. And x is still negative 2/3. Take that information, and if you were to substitute it back in, I'll just do a quick check over to the side here. 5 to the negative 3 times that x, which is negative 2/3. Well, the negatives will go away. Well, the negative, I have a negative 3 here, and then a negative 3 I can get rid of. So I really have 5 squared, which is in fact 25. So 25 does equal 25, which means that I could use that x as a value. The negative 2/3 is my answer. This one, if they both look exactly the same, well, you really don't have to do anything because it's going to be all real numbers. That's your answer. All real numbers. What? Why is that? Because no matter, it doesn't matter what I put into the place of p, it's going to balance on both sides. If I put a 0 there, they're both going to end up being the same thing. If I put a 1, 2, 3, so on and so forth. So that type problem is all real numbers. The next one, we're doing the exact same thing we did a few minutes ago by trying to rewrite it where our bases are the same. So I have 6 on this side and 36 on the other side. So if I rewrite that 6 to the second power, that still means 36. Be careful because 36 already had an exponent. So that means I have to distribute that 2 that I rewrote to everything. And also what you will see is my bases are the same. So I can get rid of them and I can just bring down my exponents. When I bring my exponents down, I have 3n plus 3 is equal to, don't forget to distribute, 2n plus 4. And once I solve for n, I'm going to subtract 2n on both sides, subtract 3 on both sides, n becomes 1. Once I substitute that information back in, I will end up with, let's see, let's do it over here to the side. So 3 times 1 is 3, plus 3 is 6, and then 36 to the, that's going to be 1 plus 2, 36 to the third power. And in my calculator, if I were to put that in there, it's going to be 46,656 for 6 to the sixth power, and the exact same thing for 36 to the third power, which means I can use n equals 1. And then finally, if I have a problem that looks like this, what I want to do first is I want to move my constant over. And I have 4 to the x plus 4 power is equal to 72. Now, when I see that I have it in exponential form and I'm kind of lost, I don't have like bases that I can go ahead and rewrite, that's when I want to rewrite it in log form. So I'm going to rewrite in log form. Guess what that means? I will have the abbreviation log. So that's the first thing I'm going to do. I'm going to write the abbreviation log. Going from left to right, I'm going to take the first number that I see, which is the base, and use it as my base for log. Go to the opposite side of the equal sign, and that's my value, and then set it equal to that exponent x plus 4. Now this is where your calculator is going to come in handy. Let me try to find my calculator again. Because we can't readily tell 4 to the what power will give us 72. So that's where, like I said, the calculator will come in handy. So what you would want to do is math, alpha, math, because that allows you to put the base in that you want, which is 4, and move over, press 72. Once you press equal, it gives you 3.08496, which I'm just going to round to 3.0850. Set it equal to x plus 4. To get x by itself, you have to subtract 4 on both sides. So x is equal to, let's go back to our calculator. I keep losing. Where'd it go? I'll get this together one day. All right, there we go. And subtract 4. And I'm just going to round it to the nearest thousand. So that's going to be negative 0.915. Oops. And that is the value of my x. Again, you could substitute that in here. And once you raise it to that power and subtract 7, you will end up with 65. That's how you know that you have the correct answer. Okay, you know the drill. Go ahead and like, subscribe, and all of that good stuff. Have a good day.